In this lecture, we are going to learn about class template specialization. And this is going to be an extension of the function template specialization feature we have learned in a previous chapter where we learned about function templates. And we are going to be applying this to class templates. So suppose we have a class template like this. This is going to be a class that has the ability to add things up. So we have a class adder. It is a class template because of this template declaration we have here. And it is going to have a method to add stuff up. It is going to take two parameters of type T. The type is going to be plugged in by the compiler at compile time. And we are going to return the same type. And down here, you see that we have an implementation of this thing. It is going to take two things, add them up, and return the result to be used by whoever called this function. So we have this class n, and we want to use it in our main function, for example. So we try and do that, and we are going to create an object of adder. We can do this. It is going to be an instance of int for this class template. And we can use it to do things. We can call our do something method. It is going to do whatever it does. We can call the add method from this object, and this is going to return the sum of 10 and 20. This is going to work just fine. If you create an object of this class template for double or long, it is going to work just fine. And then you go on and you say, I want to work with this for const char pointer strings. And you set up these strings like this, and you create an object for this for char pointer. This is going to work. And you try to do something like this and call the add method with your string parameters. And the instance is going to work. It is going to add these things up, but the result is probably not going to be what you expect. Because if you try to add two char pointer strings up, you probably want to end up with a concatenation of these two strings. But that's not what you are going to get here, because what we will be adding are pointer addresses, because the string is really a pointer to char, and what we pass here is going to be a pointer to a char, and if we add these things up, we'll be adding up pointer to characters, and we will end up with a sum, which is really a sum of pointer addresses. And if we print this out, we're going to get some garbage. This is not what we want. So if we want this add method in our class template to work, we need to specialize that to work for char pointers. And we can do this with a full specialization of our class template. We can do that using the syntax you see here. You see, we say template and we specify an empty template parameter list. This is how we do this. We specify the class we want to specialize for. So this is our adder class, and the original class template has to be available for this specialization to make sense. That's something you should keep in mind. And we say that we want to specialize this for char pointer, and this is how we say this. After we do this, we're going to go in and specify our add method and say that it is going to be working on char pointers. And what we will do in our method implementation is use the strcat facility from the CString library and concatenate this string and return a char pointer pointing to the result of concatenating these two things. Now, if we put this specialization in and the compiler sees what we are trying to do in our main function, it is going to create an object from our specialized class. So it is going to see that we are trying to create an object for char pointer, and it is going to see that we have a class specialization for that type in our code. The compiler is going to pick this up and use this to create our object, and it is going to work exactly as we would want. This method is going to be called to concatenate two char pointers, and it will return what we want. We will see this printed out on stdcout, and it is going to say hello world, as we are about to see when we run this in Visual Studio Code. But I want you to know a few things. Class template specializations are full classes. You should really know this. They are not templates. So if definitions for their members show up in a header file and the header is included in multiple files, we may end up with ODR issues. You should really know this. So they are full classes. You should treat them as such. And another thing is that it is common for beginners to think that just because our class template specialization is specializing a class template, we can just put in a few methods and specialize them and hope to get all the other methods from the class template still usable in our code. Let's try and make this super clear. We have our class template, which is going to be our adder here, and we have a do something method. And we have our add method, which is really going to be problematic if we work with car pointer instances. That's why we went through the trouble to specialize this thing. But if we specialize our class and make it work for car pointers for the add method, notice we didn't put in the do something method. We are not going to get to this method because this is really a full class with its own member variables, and it is separate from the class template that we had. The only special thing about this class is that the compiler is going to prioritize it if we happen to do something like this, and it is going to use it to create our objects. But because it is a separate class, it doesn't have this do something member function. If we're trying to call it, we are going to get a compiler error, and we want to be getting this method from the class template that we are specializing from. This is something you should keep in mind. Now that you know these things, I think it is time we headed over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is Template Specializations. We are going to be specializing a full class template and make it work for car pointers as we saw in the slides. Let's grab our template files and use them as our starting point. We are going to put them in place, and let's open this up in Visual Studio Code pretty quick. This is going to give us the main CPP file that we can start playing with. Let's do this. We're going to clean this up. And the first thing we want to do is to plug in our regular class template and make it work however we want. It is going to be adding stuff up using the add method we have here. And we have the implementation for our add method. It is nothing special. It is just going to be returning the addition of two parameters that we pass here. So if we head over in our main function and create an object of adder for int, and try to use this to add up 10 and 20, we will see the result of this printed out, and it is going to be 30 that we see. And we will see that we can call the do something method here, and it is going to do whatever it is we are doing in the body here. It is going to say that we are doing something. So let's try and build this. It is going to be working. This is nothing special. We have seen all this before. Let's bring up a PowerShell window and try to run this. Let's say rooster here. This is going to run our program. It is going to say doing something because of the call we have on line 26 here. And it is going to print out the result of adding up 10 and 20. And this is going to be using a template instance for int for our class. Now, let's see what happens if we try to use our class template for car pointer parameters. Let's do something like this, and we are going to create two strings, which are really going to be car pointers. They are going to be modifiable because this is not a const car array. It is just a car array. Hopefully you can understand this. And we are going to create an instance for this. So we say adder, we specify our type in here, and it is going to be adding C strings. We can call the do something method like we did before, and we can try adding these things up. Let's try to do that. We are going to pass this through our GCC compiler, and we are going to get a compiler error here saying that we can't really add up car pointers. And this says that I was wrong in the slides. I think I told you that we could add up pointers and get a result, but this is not even going to work. I had missed that point. What's the point of adding up pointer addresses? It doesn't really make sense. You can add a number to a pointer to make use of pointer arithmetic, but adding up two pointer addresses is probably going to give us a large number, which may even overflow the memory range that we have in our C++ program. So C++ compilers are even going to prevent you from adding up pointers, and this is not going to work. That's the error we see here. And this is the point of trying things out. You even find more errors that you didn't think you knew about. Okay, but the point here is that this is not going to work, and we would really like the add method to work to concatenate strings. What we would want to get if we do something like this is to get a hello world string from this and print it out on the console as we do this. To do this, we could go the path of fully specializing this class template for car pointer, and we are going to do that. So to make this work, I am going to put my class specialization down below here. This is going to be our template specialization. We are going to say template and specify an empty set of angle brackets here. This is going to tell the C++ compiler that this is our specialization. We are going to say the type we are specializing for using these angle brackets and put the type in. This is the syntax. And after that, we are going to put in our method and make it do whatever it is we want to do. So we are going to specify our parameters and our return type to be car pointer. And this is going to be our definition for this member function here. Notice that we don't need to put the template declaration again. If we do this, you are going to get a compiler error. C++ works in a way that it is going to know this from this template declaration we have on top. So we don't need to put this line here. That's why I put a clear comment to make this super clear here. Now, in the body of this member function, we are going to use the strcat facility from the C++ standard library. This is going to concatenate our two strings, and the result of that is going to be a car pointer pointing to the concatenated string, and we can return it and use it in our C++ program like we are doing down below here. We need to include the C string library though for this to work, so let's do that. We can put this in. The moment we do this, the line below here should work. And if we go down, we are going to see that we can't call the do something method anymore because a class template specialization is a full class on its own. It's a fully new class, which is really separate from the class template, and it has its own member variables. It has its own setup. It is a different class from the class template. The compiler is just going to prioritize this class if we create an object for the type it is specializing for. So we have no business calling this method here. If we call it, we are going to get a compiler error. But what I want you to see is that the code here is now going to work because line 51 here is going to use our class specialization for car pointer, and it is not going to use the class template here because the compiler says if you went through the trouble to specialize the class template for car pointer, you probably know better. I am going to use your implementation to create objects for this class template if you happen to be using this type to create your objects. Hopefully this is making any sense. Let's go down and put in a simple separator to make sure we see this if we run this program. And we are going to say stdendl. Let's build this with GCC. Hopefully it is going to work. The build is good, so this is a good sign. We can clear and run rooster. We are going to see that now our specialization is being picked up to create objects of car pointer for the other class. And this is really cool. Now, know that you want to be able to call the methods you had in your class template. If you didn't explicitly put them in your template specialization, for example, the do something method here is not available in our specialization, and we won't get that from our class template because this is a completely separate class we have in our C++ program, and the compiler is going to use it to create objects of this type that we set up here. So that's why we have a squiggly line here. Again, if we try to compile, we will get a compiler error saying that we have no such method in our adder class. That's what we see here. Class adder has no member named do something. So this is the compiler error I wanted you to see, and you need to be aware of this. Another thing you should know is that because this guy is not a class template, it is a full class. If you happen to have this guy in a header file, and the header is included in multiple files, you will get ODR issues that we didn't get with our class templates before. To really show this, I am going to create a header file. Let's do that. And I am going to say adder.h. And I am going to move my class template and specializations in that header file. And I am going to include that from here. So let's grab the entire thing here. I think it is going to go in that adder file. We can do something like this. Let's paste this in place and let's make sure this is everything we need here. I think it is. So we can go in main CPP and include adder. That's the name. It is adder.h. We need to rename this. Let's do that. So rename adder.h. This is going to do. If we go to main CPP, we see that we have this in place. And if we're trying to run our program, let's make sure we do that. We're going to pass this through GCC, and the build is going to finish successfully, and we can run our program. Let's do that and run Rooster. This is going to work just fine. But if we set up another CPP file, for example, and let's do that, we are going to say some other file.cpp, and we go in this file and try to include our adder file. This is going to bring in everything we have in here, and that's going to include the member function implementation we have here. But remember, this is true C++ code. It is not a class template. So this is going to cause ODR violations because now we have two definitions for this method in our C++ program. Let's make sure you see this if we try to build and run this. Now we are going to build with errors, and we are going to see that we are redefining this method a lot. Let's really show you the error here. So void adder, do something. We don't have this method in here. What is wrong here? And this is saying that stdcout is not a member of std. Why is that? Because we don't have this included in adder, but we can do that. I think we can say that here. So we can move our include for IO stream in this location here. This is not the error we want to see. We want to see the redefinition error because we have two definitions for this method here in our program. And according to the one definition rule, we shouldn't be able to do this. Let's try and build our program. So we're going to pass this through GCC again. We are going to have an error again, but now the error is going to say multiple definition of this function here. It is going to be multiply defined. It is going to be available in the main CPP file because we are including adder. And if we do an include like this, the preprocessor is going to take everything we have in the adder header file and paste that in our main CPP file. If we go in some other file CPP and include that thing, this is going to be pasted in here. And we are going to be ending up with two definitions for this function here. This is something I want you to know. You should be aware of this. Now, because this is real C++ code, if you want to avoid ODR violations, you can take the implementation and move that in a completely separate file. So for example, we can set up an adder.cpp file and do that. So we're going to say adder.cpp, and we're going to move that in here. And this is going to be picked up by the compiler, and this is no longer going to cause problems. But for this to work, we need to include the header file for adder. So let's do that. And now if we build, we should get rid of that redefinition linker error that we were facing earlier. Let's make sure we build our program and pass this through GCC. Now the build is going to be good and everything is to work just fine. Let's see why we have this error here. Why? Include errors detected. Please update your include path. This is probably Visual Studio Code playing tricks on us. We are going to ignore this because our program is working anyway. Another way we can get around these ODR violations is actually by marking this function as inline and keep it in the header file. So we can do something like this. We can comment this out. I really want you to see that. So let's make sure we comment this out, and we're going to take the code here and move that back in the header for our adder function. And we're going to put the implementation where it was, but we are going to mark that as inline. What this is going to do is going to constrain it to the translation unit where it is going to be showing up. And this won't violate all the one definition rule that is really crippling us. Let's make sure we build again. We solve this by marking this function as inline. And this is going to constrain it to this translation unit here where it is showing up. If we try to build the code, let's pass this through GCC. The build is going to go through and everything is going to work as expected. So let's make sure we clear properly and run Rooster, and it is going to work exactly as we want. We see our hello world message here. This is really all I wanted you to see in this lecture, showing you that it is possible to do a full specialization for a class template. Again, this is specializing the class. Later, we will see that it is possible to specialize a single method in an entire class if that makes sense for our program. If we set up something like this is going to be a completely separate class from the class template. And what that means is that you want to get access to methods from the class template if you don't explicitly put them in your class here. We saw that by seeing a compiler error if we try to call the doSomething method. The compiler is going to prioritize your specialization to the class template because it thinks you know to do better for the type that you specialized the class template for. That's why your class here is going to be chosen to create instances for car pointer objects for the other class. I hope this makes sense. Another thing is that because a class template specialization is a full class, you can't have implementations for its member functions show up in multiple headers. If you do that, you will be subject to one definition rule violations. We saw that we could solve this problem by moving our implementation either in the CPP file or by marking them as inline. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, I am going to show you that it is actually possible to not fully specialize an entire class template, but only specialize select methods in a class template. And this may come in handy, especially if you have a really large class that you don't want to fully specialize. We're going to look at that in the next lecture. Go ahead and finish up here and meet me there.